Hi guys, heat and transfer now for 9.2. So heat transfer, how is heat transferred from one thing to the next? We talked a little bit before how heat is going from one thing to the next. It's a transfer of thermal energy, but how does it transfer is what we're looking at. And you guys have actually done this. You guys have talked about it with your 8th grade standards quite a bit. So first, the learning target, I can compare and contrast transfers of thermal energy. So conduction, convection, radiation. You need to be able to explain what how thermal equilibrium occurs, and then the difference between, and give examples of conductors versus insulators. We should be pretty good at this, I believe. So not a lot for this section. First thing, heat transfer is that flow of thermal energy from one thing to the next. It's heat going from this to this. It's something warming up. And that can happen in three ways. We have conduction, convection, and radiation. So the first one, conduction, is the transfer by contact. And that can be like contact of molecules in the air or solid, like the more particles in the spoon can transfer from particle to particle to particle all the way up that spoon, as you can see here. The hot chocolate is what's hot, yes. We put the spoon in it, and that hot chocolate contacts only part of the spoon, but that heat can eventually travel all the way up to that top of the spoon, and that is through heat conduction. Transfer of heat by the direct contact or the collision of particles of matter. Okay, some particles have more energy than others, and they don't want to have that. Okay, we don't want to be at a high energy state. We want to disperse of our energy, and we want to lower our energy. Okay, you guys get that? I get that. I have a 2-year-old that I do not want him to have a lot of energy. I want him to have a lower amount of energy, so I make him go downstairs and burn off that energy somehow. Sometimes maybe we need to invite a friend over so that they can burn off that energy together, right? So same thing, we want heat energy, we want the energy to be as low as it can be, so that heat that the hot cocoa has will transfer to the spoon that has less energy, right? And then that energy will work its way up the spoon until eventually those temperatures are the same. That is when we get to thermal equilibrium. When all touching materials are at the same temperature, no heat flows when objects are in thermal equilibrium. And what we're really talking about here is any objects in that system. Okay? Really, if you have a hot chocolate and a spoon sitting on a table, they will continue to give off heat until they are basically the same temperature as your room, right? Eventually, hot chocolate sitting on the table will cool off and it will be room temperature eventually. And that is what thermal equilibrium is. Okay? My dad would always, when I was younger, we'd leave a door open or something like that in the winter or in the summer, doesn't matter. And in the summer, he would say, "What are you trying to do? You're trying to air condition the entire town, or you're trying to heat the entire town? It's not going to work, right? The heat or the so the heat will be leaving our house to go and warm up the outside, right? Until it would do that, our heater would continue to work until it is the same temperature everywhere. We don't want that. I do not want to pay to heat up our entire atmosphere. So that's not a good idea. But that's what thermal equilibrium is, when all things in that system are the same temperature. Now, the difference between conductors and insulators. So a conductor is a material that conducts heat very easily. A conductor would be like that spoon. That's something that heat can travel through that spoon very quickly. Or a hot pan. Not even a hot pan, just a pan in general. We want heat to travel through that pan very quickly, very easily, right? We don't want we don't want it to absorb, or we don't want the heat to be stuck there. We don't want it to be a barrier. We want that heat to pass through that pan, no problem, because we want the heat to go to the eggs or the water, whatever we have in our pan, right? An insulator is the opposite. So many of your pans probably have like a plastic handle on it. That plastic handle is your insulator. We don't want heat to travel to the part of the pan that we're going to touch. So we put an insulator on that, and that insulator does not allow the heat to travel through it. Your jacket is an insulator. It wants to trap that heat in by you. It does not want your body to heat up the outside. That would be bad news. It would take a lot of calories in order for you to heat up the entire atmosphere. Okay? Typical conductors are going to be metals, copper, gold, aluminum. Those are your kind of typical conductors that we're going to use. Insulators are going to be things that do not let that heat transfer. So styrofoam, plastic, wood, those are good insulators. Convection now. You guys definitely know about convection. You've learned about it from 8th grade. That's the transfer of heat through the motion of matter, such as air and water. A lot of times, when you guys think of convection cells, you might think of in the mantle and that magma movement in the mantle and that pulling of the tectonic plates. That would be convection. Okay, that circular motion of the fluid inside the earth, that is convection cells. That also happens in our atmosphere. We have a circular motion of wind, and so we have areas of high wind and low wind, and that's the convection. That is due to convection cells. Transfer of heat through the motion of matter, such as air and water. You can see this pot. We have circular motion. We have that heat rising, right? So when things become warmer, they become less dense and they rise up. More dense goes to the bottom. So as things rise up, they move away from that heat source, right? We have the bottom pan the bottom, the burner is supplying our heat. So as we move up towards the top, that water's starting to cool down. Well, that less dense water, or that more dense, cooler water will go back to the bottom where it heats up and becomes less dense and rises up to the top. And that is how we get those circular motions, those convection cells. And that's what boiling really is. Convection is how most heat is transferred through a system. If you have air going through your system, you have that warm air rising up to the top and that cool air falling, and that is a continuous cycle. Radiation is the last of those three, and radiation is how we get our energy from the sun. So it's the transfer of heat by electromagnetic waves. The difference between radiation and convection conduction is that radiation does not need particles to conduct or to transfer. Okay? Conduction, we have to have particles colliding. Okay? Convection, we have to have particles moving. Thermal radiation is not particles. It is electromagnetic waves, electromagnetic energy. So that is how we get that heat, that thermal energy from the sun to the earth, where in space there are no particles, right? We can't have conduction in space. We can't have convection in space. Okay? So we have thermal radiation is how we get that energy from the sun to the earth. And then different processes in the earth convert that thermal radiation into heat so that, and then we can feel it and it gets hot, things like that. Okay, the higher the temperature of an object, the more thermal radiation it emits. If you guys remember a few months back, there was a child in Becker that went missing, and they ended up finding him using some infrared heat vision on a drone, right? And using that, so the child is emitting heat, right? So this infrared camera picks up the heat that is being emitted. So they saw in the middle of this field this heat being emitted, and they learned that that was the child and the dog, and that's how they found him, was using this thermal radiation, this idea of every object that has heat gives off this radiation, and they used that radiation to find him. Super cool. And I used to do, actually, when I taught 8th grade, I used to do a lab like this where you can literally like take pieces of cardboard and you paint one black, you paint one white, and you can see which ones actually heat up more. Okay, different objects are going to absorb that radiation and different objects will reflect that radiation, right? Thermal radiation is absorbed by objects. The amount of thermal radiation absorbed depends on the surface of that material. The color makes a difference, the type of material makes a difference. That's why like a blacktop road might melt that snow, or it might stay black longer than the green grass that the snow also falls on. If you watch in this winter, snow's falling and it's just kind of a light snow. When it hits the road, it might melt right away, versus when it hits that grass, it might stay there, right? It doesn't absorb that heat. That grass doesn't absorb it. It reflects it a little bit more. So it's not going to have as much energy as that black road absorbs more of that heat. So dark surfaces absorb most of the thermal energy, thermal radiation they receive. Silvered or mirrored surfaces reflect thermal radiation. And that's it. That's all I have for you for this section. Hey, thanks guys again. Yeah, thank you very much.